So, you want to learn how machines learn, but you're a busy person, and you don't have time to waste learning linear algebra, multivariable calculus, Bayesian statistics, or other complicated sounding terms that mathematicians use to stroke their fragile ego. You want to know how to throw around buzzwords to cash in on some of that big tech AI money. You want to know how to create the boogeyman keeping Elon Musk up at night.
I tried to convince people to slow down AI. This was futile.
You want to know why Facebook's engineers are yet to release a more human-like Zuck Android.
Hey everyone, we are live from my backyard where I am smoking a brisket and some ribs.
Well, lucky for you, all those questions will go unanswered as I explain the basics of how machine learning and AI works. Although people often use the terms machine learning and artificial intelligence interchangeably, this is a mistake. Machine learning refers to just one approach to designing artificially intelligent systems, and, up until the past few decades, it wasn't a very popular one. Prior to the recent boom in machine learning, most AI researchers focused on what is now known as good old-fashioned AI. This involves human experts defining a knowledge base and a set of rules, which can be queried in order to tell us new things. For example, you could have a knowledge base which states that Mark Zuckerberg is not a lizard person.
I am not a lizard.
And we can also add to this knowledge base that Mark Zuckerberg is not a human, and that Mark Zuckerberg is humanoid in form. Now, if this system also has the rule that an object is a humanoid robot if that object is humanoid in form, and it is not a human, and it is not a lizard person, then, using facts and logic, we can conclude that Mark Zuckerberg is a humanoid robot. What has this got to do with AI? In good old-fashioned AI systems, this information is encoded symbolically, so that a computer can automatically answer queries relating to the knowledge base, using the rules available to it. But this approach to AI has a major limitation. The humans designing the system need to know all of the relevant rules and knowledge ahead of time, otherwise the AI system will not be able to correctly answer queries. This is where good old-fashioned AI starts to look less good and more old-fashioned, as the past few decades have seen machine learning step in to solve this sort of problem. In machine learning, instead of providing the system with knowledge and rules, we provide it with data or experience to allow it to learn its own rules for mapping inputs to outputs. For example, if I want an AI system to tell the difference between a picture of Zuckbot and a picture of a normal human being, it is unclear what rules I could give the computer for this to be achievable with good old-fashioned AI. Instead, we provide a dataset containing many images of Zuckbot and many images of ordinary people, to a machine learning algorithm which can then learn how to classify whether a human-looking figure is actually the Zuckbot. There are many different machine learning algorithms which can be used to train models to perform this sort of classification task. But you don't want to hear about decision trees, random forests, gradient boosting, extra trees, XGBoost support vector machines, k-nearest neighbors, or logistic regression. You want the good stuff. You want to know about neural networks and deep learning. Artificial neural networks are a mathematical model inspired by the biological neural networks found in brains. They consist of a number of layers of neurons connected to each other by weights. We encode the inputs and desired outputs for the neural network as vectors, which can be thought of as lists of decimal values. In the case of classifying images of Zuckbot, we can flatten the array of pixels forming the image into a list of decimal values for the input, and we can let the output be a list of two numbers, with 1 0 indicating the images of Zuckbot and 0 1 indicating that it is not. Now, given some input, the neural network performs a number of mathematical operations to map it to an output. The great thing about neural networks is that they are universal function approximators. This means that any computational rule for mapping inputs to outputs can be approximated arbitrarily well by an appropriate neural network. The problem now becomes one of finding the right neural network for a given task. This is where our training data comes in. By providing training images to a neural network with randomly assigned weights, we initially get random predictions for their outputs. However, if we iteratively modify the neural network's weights in order to reduce the error between the predicted outputs and the desired outputs, then at each iteration our neural network will get better at correctly classifying which images are of Zuckbot. In other words, a neural network learns by optimizing its weights in order to minimize the error between its predicted outputs and the desired outputs for a given set of inputs. This optimization is performed via gradient descent and backpropagation, but I won't bore you with that level of detail. You want to know if any of this actually works. Well, lucky for you, I've decided to waste my time making a Zuckbot classifier. First, I downloaded a pre-trained version of Google's FaceNet model, which is a convolutional neural network similar to the sort of neural network discussed here, but better at handling image data. Then, after using glib to extract faces from image, I use FaceNet to embed faces in a vector space where more similar faces are closer together. I then provide a set of reference images of Zuckbot and say that a face is Zuckbot if its embedding is within some distance threshold of the reference images. And voila! We can now automatically detect whether a humanoid figure is Zuckbot or a regular human being. But so what? We can classify images. Well, variations and extensions from the ideas used here can be applied to help your Tesla avoid becoming a sci-fi trolley problem.
Slow down, AI.
To keep serving you TikToks that you just can't look away from. To beat humans in games like chess and Go and poker and StarCraft. To help high-frequency trading firms send every self-appointed day trader on Robinhood broke. To generate art and text and code, putting us all out of our jobs and ushering in the end of humankind. Or not. Maybe once we all get Neuralink to play mind pong with monkeys, we'll discover that we aren't all that different from Zuckbot and our AI overlords after all.